Excuse me, sir.
Okay, so in the two places we have the atomic conversion meters
Hello, sir.
available
Excuse me.
to see. And I think the last time we went to Dharwad Agri
Hello, sir.
University, I took our COC students to one of the research center there. So wherein uh, one of my friend is there working in this agri part of the agri university. They are like a KVK, but it's a central one. So there he is using atomic absorption spectrometer for the analysis of various metal contents that they come across in the soil analysis. So we could able to see those instruments and which is working there. Um, maybe in this scenario it may not be possible. And in KVK, sorry, in soil and centricity, one of my student is was working as an analyst. Was handling atomic absorption spectrometer. Okay, so I think having studied or having um attended the class on this particular topic of instrumental methods of analysis, so should be able to grasp the things and they should be able to use that instrument for the real time and in the real time purpose. So also told in the last class that when you go for a job in chemistry, then people ask you how many instrument that you have handled. So that experience counts a lot. Uh, now let us go with another technique today. Okay, so after limiting ourselves to the discussion of AAS, I just say we are limiting because so the day by day lot of advancements are taking place in the field of analysis. New type of instruments are coming. So then new challenges will be there, new advantages will also be there. So those things are not taken for the discussion. We just have to limit ourselves to the syllabus boundary. But however, when you know some basic concepts, then adapting yourself to the new scenario, new circumstances should not be a difficult one. So now let us go with the um, thermal method of analysis. So I think this is entirely new concept to you. And I just tell you one more thing that soon after this class, the class on thermal analysis, there are four subclasses here. So after that, I will be handling one of the very important and very useful, very interesting aspect of spectroscopy, that is a NMR, nuclear magnetic resonance spectroscopy. Okay, so NMR technique is going to be, so I don't know how many of you are going to opt for chemistry in your PG studies. So for all those such people, okay, so NMR is a very essential, not just in chemistry. Those who would like to continue their higher education in the allied fields. Uh, 1 second, I'm just one more. Okay, is this audible?
Yes, sir.
Wait, okay, now I have allowed you to unmute yourself. Somebody would like to speak. Some Pawan raised the hand. You can just unmute and speak to me. Pawan Naik, would you like to speak? Or do you have? Is there any problem? Is this audible first of all? Yeah, now you can unmute yourself and just react me.
ಹಲೋ ಸರ್.
ಹಾ
ಸರ್ ಅದು ಅವಾಗ ವಾಯ್ಸ್ ಸಣ್ಣ ಕೇಳ್ತಿತ್ತ, ಅದಕ್ಕೆ ಸ್ವಲ್ಪ ದೊಡ್ಡ ಕೇಳಿ ಆಗಿತ್ತು ಅಷ್ಟೇ. ಅವಾಗೇ ರೈಸ್ ಮಾಡಿದ್ದೆ.
ಸರಿ, ಓಕೆ ಓಕೆ. ನಾನು ಸ್ವಲ್ಪ ಇದು ಸಣ್ಣ ಇತ್ತು. ಓಕೆ ಓಕೆ ಓಕೆ. ಐ ನೌ ಇನ್ಕ್ರೀಸ್ ದ ವಾಲ್ಯೂಮ್. ಫೈನ್, ಥ್ಯಾಂಕ್ ಯು. ಆಲ್ ರೈಟ್. All right, so I think I did tell about these instrumental methods of analysis so far. What we had a discussion on the atomic conversion spectroscopy. So I just tell a few things, no problem. So I took my students to the Dharwad, wherein they could see, the COC students could see the working of atomic conversion spectrometer, and two more such units are here in Sirsi also. So in the soil center, one of our student was working there, handling this instrument. This is a quite useful instrument for analyzing metal contents. Normally, it is used in the agricultural analysis because the metal contents that are present in the soil can be easily and accurately analyzed. Okay, the essential metals and even the rare earth metals. So be it anything, any kind of sample, one can analyze them with a greater accuracy. So there are so many such advances, and of course it is not just in the field of agriculture. So it's in the field of medicine, food, medicine, so whatnot. So it finds a lot of application. It all again depends on the requirement. If any field uh, it requires the the presence of metal content to be analyzed, then the better choice of today is to go with the atomic exhaustion spectrometer. Okay. So similarly, we are now going with a discussion on another technique of the thermal analysis. And also I was telling that after these things I'll be talking about the very important part of the spectroscopy, that is the NMR, nuclear magnetic resonance spectroscopy. So for those who are willing to go for their higher studies in chemistry or allied subjects, chemistry allied subjects, not just for them, even for you, even if you don't have that idea also. So this is a very interesting technique, interesting the concept, useful, interest, important even from the examination point of view also. But I just give one the notice that NMR technique, it involves some quite conceptual aspects. Okay, so which is again a new things to you. So I think all these things what I am discussing, so these are the entirely new aspect that you are encountering, because most of the times up to fifth semester, the many part of your syllabus were already came up in one or the other way since from your school days. But these years, means fifth and sixth semester, you are seeing some of the syllabus. They are not at all. You couldn't have a glance of them much earlier. Okay, so this needs, you need to welcome these things with the interest, curiosity, and also the attentiveness. Fine. Now let us go with the let me go with the today's talk on the new topic. So that is a thermal analysis. Thermal analysis. So when you just look into this particular term, okay. So then what it infers uh, is you are doing some analysis with the help of some heating process. Okay, so you are going to make the analysis with the assistance of heating, or by heating what is going to happen. Okay, so this is going to be quite interesting. uh, in this heading we are actually, what is mentioned in your syllabus is that TGA, DSC, and DTA. Okay, so there are some short forms that you are going to encounter, and so for all of them, the major class is a thermal analysis. All these the terms that I told, so they come under the heading of thermal analysis. So what it can be, how it can be defined is it is a branch of material science. Okay, just look at this. It's a branch of material science where the properties of materials are studied as they change with the temperature. Okay, so then you can start imagining yourself that what are the properties that are going to change with the temperature. So what all you think that such kind of analysis is there, that's all. Okay, so you just keep on heating a material and observe what happens to one particular fixed property. Okay, and if you do that study, whatever it could be, then that can be called as a thermal analysis, right? So there are several methods are commonly used. Okay, so these are distinguished from one another by the property which is measured. Okay, based on the property that is measured, there are several subclasses of this title called thermal analysis. Let us not go into these abbreviations. Let us look into these things later. Yeah, now here you see the subclasses of these major heading of thermal analysis, and you can notice some of the short forms here along with the full form given in the blue color, and on the right side in the dark colored letters the wordings. So what is given is that the property which you are going to measure. Okay, so DEA stands for dielectric thermal analysis. Okay, so this is a dielectric permittivity and loss factor. So this is the property you are going to study for a material as it changes, okay, with the change, continuous change in the the temperature. Okay, and differential thermal analysis. Okay, so the temperature difference. So we go in very detail quite later, but actually this is there in your syllabus. DTA is in your, is mentioned in your syllabus, and then differential scanning calorimetry. Okay, differential scanning calorimetry. Be careful, this is not colorimetry. Okay, calorimetry. I hope you can clearly distinguish this. Okay, so you are going to study this. DSC is also mentioned in the syllabus. So here the entity that you are going to deal with is a heat difference. It is a heat difference, and here is the temperature difference. So they are different. These two are different. Okay, here there is a temperature difference, but here there is a heat difference. All right, then dilutometry is a volume variation with respect to the temperature. And then dynamic mechanical analysis, mechanical stiffness and damping, DME. And then EGA, evolved gas analysis, gases decomposition products. Then laser flash analysis, thermal diffusivity and thermal conductivity. Then this is quite important. That's a TGA. Okay, Thermogravimetric Analysis. So thermogravimetric analysis. So change in the mass. Okay, change in the mass, of course, in the sense weight. Okay, so this is also called as a weight loss or weight gain, right, in the due course of heating. And thermomechanical analysis, TMA. So this is a dimension, variation in the dimension of the material. Then thermo-optical analysis. So if there is a change in the optical property on heating, so then that is TOA. Look at these things, the diversity. Okay, rather I would have asked you, I used to do ask this question in a normal classes when I used to begin this talk on thermal analysis. The very simple question was, what happens if you set a material ablaze, if you set a material into the flame, so then what is going to happen? So this was my the usual question to begin with this class on thermal analysis. Of course I forgot, but still now we can just answer is in front of you. Look at the varieties of things that happens when you just heat a material. Okay, so a lot of its properties is going to change. Even if it is a if a material is fuel, fine, it burns. Okay, if a material is a fuel, then of course it catches fire and it undergoes decomposition. Okay, and there's going to be a lot of chemical changes, and in due course, so there is a decrease in the mass of the substance. Okay, whatever the fuel that you have put, so that mass is gone. Okay, that is because of the heating. And sometimes if the material is not a fuel, but still it undergoes some variations when you put in a when you put it into flame, then the dimension might change. Okay, there is a its volume might change. Okay, and if it may undergo deformation. Material, the entire material will undergo deformation. Okay, so that's the dimension changes. And if the material is having some optical property, so that might undergo variation. Okay, so if it is a transparent material, that might undergo translucent and opaque. So a lot of things might happen, right? And uh, weight gain is also possible. Okay, on heating, some of the material gains the weight. This you might find it very interesting and difficult to locate it at this time, but later you come across with such examples. All right, so a lot of things does happen, and of course, so these things, what you see, these two things, differential, wherever you say differential, DTA and DSC. So these are some again little different technique in a sense. We make a differential studies. Differential studies means we take your sample and another standard inert reference is kept along with that, and simultaneously we keep on giving the heating program to both the entities. The standard reference is such that it is highly inert. Okay, which do not undergo any kind of changes, rather chemical change or physical change in that working range, in that heating program. I use the term heating program here. There is a technical term not normally used in this thermal analysis. Heating program is, in the sense, it involves two parameters. So maybe I come across that later, but I just tell you now. It involves the temperature up to which you are going to heat and the rate at which you are going to increase the temperature. Okay, all this put together, it can be called as a heating program. Okay, the maximum temperature that you are going to attain. Okay, and also when you are heating it, when you are heating a material to that maximum temperature, so what is your rate of heating? So how the heating is increasing? Is it suddenly or increasing, or slowly or making changes? Of course, they are going to make a lot of differences. in the variation of their properties. Okay, now given a heating program, if you start comparing two materials, one is highly inert, no change happens in that heating program, and another undergoes certain changes. So this difference will help you a lot many, will give you a lot of information. Okay, and that is quite useful. So you all are going to certainly appreciate these techniques in the next few classes of mine, so that you if you look at their utility, then certainly you have to appreciate these things. All right, now our main focus among all these things are not going to be studied. Okay, so among this major class called thermal analysis, for the first thing that I am going to discuss is the TGA, Thermogrammetric Analysis. Okay, and this is not included in our discussion because this is going to help with mostly the engineering studies, right? But however, we limit to the chemical analysis, then we take up this TGA and these two techniques here, DTA and DSC. These three are going to be studied in our syllabus. They are mentioned. Another term is there, DTG. That is not a different technique. I tell you later. Okay, what are mentioned is TGA, DTG, DSC, and DTA. So a lot of short forms are coming. So you need to be quite alert even in the examinations. Okay, even in understanding these things. And others, it has been mentioned here, but to make you look at. So these are the things that are there, but they are not being studied in our limitation here. Okay, so yeah, I think the same the chart in a different way it has been put here. Let me not go it again. Fine, let us go with some introductory slides here. It is thermal analysis is defined as a series of techniques for measuring the temperature dependency of a physical property of a certain substance while varying the temperature of the substance according to a specific program. Program here means specific heating program normally. The substance referred here includes the reaction products. The substance here means the analyte as well as the reaction product. All right. The physical properties include mass, temperature, enthalpy, dimension, dynamic characteristics, and others. Okay, and depending on the physical properties to be measured, the techniques uh, uh, the techniques are classified as the subclasses of this thermal analysis. Okay, so normally these are the major aspects, the properties that we are going to study. Change in mass, okay, the temperature difference, enthalpy difference, and dimension analysis, and many dynamic other characteristics like optical property, dielectric property, and so many things. Okay. Conventionally, thermal analysis has been mainly employed in measurements for research and development, but in recent times it is used in many practical applications as the testing standards on the basis of thermal analysis they have been established. So we come across this point later. For example, in quality control, uh, in the production field, process control, material acceptance inspection, this thermal analysis are being used. Okay, it is also applied in wide fields including polymer, glass, ceramics, metals, explosives, semiconductors, medicines, and foods. Okay, so the field of pharmaceuticals, okay, the field of pharmaceuticals, the field of polymers and glass, so this field have exploited in the sense they are extensively using the thermal analysis, because of course this what we are studying is a material science. Okay, you come across with any new material or anybody in this globe, if working on a material science research, they will come across with this particular study. They have to, one or the other way, they have to use this thermal analysis for establishing their material property, okay, or for characterizing their material property. So they have to use this thermal analysis. Okay, so now what I do is, so these slides, it's having a lot of, okay, this PPT is having a lot of slides, but it is specially, it was prepared for this pharma as well as polymer industries. So there are really wide utility of these thermal analysis in these two fields. So I just look at some of those aspects, and I go to, or I might limit the discussion to our chemical aspect, chemical analysis, analytical aspect. Okay. Now let us look into the basic principles of thermal analysis in general. Okay, so the modern instrumentations used for thermal analysis, it consists of these following entities: the sample holder or a sample compartment, okay, for keeping the sample. Okay, so that is a sample is the one which you are going to study the variation of any kind of desired property. Okay, and sensors, you have to have a suitable sensor to detect or measure a property of the sample and the temperature. Okay, you need to have two sensors here. One sensor should be continuously measuring the temperature, because you're studying any one of the property with a continuous the continuous change in the temperature. Okay, so that's how these are the two essential aspects here. Sample compartment, of course, that's there, should be there, and two sensors. One sensor is of course for a temperature, and another for your desired property. Okay, if it could be a change in weight, it can be a change in dimension, change in the uh, what you call dielectric property. So it all depends, for depending on the property, you should have that particular sensor which senses the certain variations. An enclosure within which the experimental parameters, uh, that is a temperature, speed, environment may be controlled. Okay, so all these control units should be there, and a computer to control the data collection and processing. Okay, so then you have a controller in which you can control the temperature, because you have to put in a furnace, isn't it? So you are, as you are studying the variation in the temperature, then your sample should be kept in a furnace. Okay, the furnace is the one wherein you are giving you're increasing the temperature of the sample. Okay, and there is a suitable compartment or a vessel to hold the sample. Everything should be there, and yeah, these are the main three things that you see here. The control means you can just have a control on the temperature. Means how, as I told earlier, you can have a control on heating program. So how fast, what should be the rate of heating, that you should mention, and what are the maximum and minimum temperature to attain or to pass through. So and also what is the inner atmosphere of this furnace, that's also important. Okay, because there is one technique already told, there is evolved gas analysis, EGA, means on heating a sample, okay, this sample produces some gas. Okay, and this gas can also be studied, that is further connected to some other type of techniques. Okay, and that gives you a lot of other informations. So like you have to have a control over the atmosphere of this particular vessel or a furnace. Okay, all this control unit should be there. It is mentioned here as a block, and this is a furnace, and finally whatever you do, you should get a result, and this data should be processed by a computer. Okay, I should tell you at this stage that in my research work while I was doing a PhD, I have done this all this analysis. Okay, what I am teaching you here that this TGA and DSC and as well as the DTA. So these things, these analysis I have done for my samples, the new molecules that I prepared for them, for all of them. I have done this analysis and all the spectral, all this analytical data are also with me. So maybe in the classes to come, I can show some of the real time the result sheet of this analysis. Okay, and how to have an interpretation of those the resultant this analytical data. All right, so let us have those discussions gradually. Thermal analysis of pharma materials. Now, this is what I said. There are a lot of slides here. I just skip these things so that we limit ourselves to the general aspect of thermal analysis. Thermal analysis in a pharmaceutical. So this detailed discussion can also be done. Fine, let us limit ourselves further. Let me read on this here. A group of techniques, as a UPAC definition, a group of techniques in which a physical property is measured as a function of temperature, while the sample is subjected to a controlled temperature program, as a heating or cooling or as a thermal. Okay, so anything it could be. So when you are doing this, then if you measure a property, that is called as a thermal analysis. All right, now, so let us look into these three in a very short form. This is a measure, TGA measures the change in weight during the heating or cooling program. Okay. Now in case of DTA, okay, differential thermal analysis, they are used for thermal investigation where the thermal change can be observed and characterized. So this definition you may not grasp it unless I go in very detail. Fine. In case of differential scanning calorimetry, measure heat absorbed or liberated during the heating or cooling effect. And this TMAs measure the change in dimension during the heating or cooling. So this we are not studying as it is not included. So these three are there. Yeah. Now this is where I was looking about the thermogravimetric analysis. Fine. Now I think you can have some. I can make a little thinking on this particular title. If I remove this T, the prefix, but you know this, gravimetric analysis, isn't it? You know the gravimetric analysis, but we are just appending the prefix of thermo. Okay, so kind of the heating, right, to this gravimetric analysis. Okay, so now in that perspective only, if you think, what is meant by gravimetric analysis? So you all know that it is a quantitative analysis in which you make a determination of an analyte. Okay, so by the process of weighing, gravity stands for weight of the substance. Okay, so the entire analysis in gravimetric analysis, the entire the purpose is solved finally by the weighing. If you just recall the all the processes. Okay, so in this semester, actually the lab session does involve gravimetric analysis. Okay, so I think you have studied gravimetric analysis in the theory. Now that maybe in the last semester, that actually you are going to apply in the laboratory sessions of this 6th semester. Okay, you're going to do the gravimetric analysis of I think iron, aluminum, and barium. So and lead is also there. Normally we do these three. So these things you are going to do the analysis. So if you recall, what happens, the given analyte is converted into some weighable form of a suitable chemical composition, and then it is when it is in the solution, you have to filter, you have to dry it, and finally you have to ignite it to a stable composition, and then you have to take the weight in a silica crucible, pre-weight silica crucible. Okay, and based on the weight that you measure finally, the based on the weight of the the analyte, which is converted into a one fixed chemical composition. That is quite important. Okay, so whatever be the analyte, your analyte is converted chemically converted into a stable material which retains its stability at even at high temperature. Okay, so that we normally heat it in a crucible wherein all the combustible materials that are present will go off, and leaving behind your stable compound, okay, with a precise chemical composition. And then by knowing the weight of that residue, okay, so your analysis is achieved. So that is what actually the gravimetric analysis is. But when you append thermogravimetric, the term thermo, and when you see the TGA, it might, there is some similarity, but not entirely with what you have seen, what you have done there. But it is something to do with the measurement of weight while heating. Okay, thermogravimetric analysis, it involves the measurement, the heat, the weight measurement, or continuously or to take the weight of the sample while the heating program is applied. Okay, now let us go with the principal definition and instrumentation aspects and utilitarian aspects of this particular technique called TGA. TGA measures the amount and the rate of weight change of a material with respect to the temperature or time in controlled environments. Okay, so this is what it says. So we are going to measure the change in weight of that particular analyte sample material with respect to the temperature. Okay, now what is that? See, the major class of this analytical method is thermal analysis. And among thermal analysis, the subclass here you are going to study is thermogravimetric analysis. Because in thermal analysis, what is now added is a gravimetric. Gravimetric is the weight. Okay, what you are going to measure with respect to the heating program is the change in weight of the sample. Means on heating a substance, the substance might gain the weight or lose the weight, and the instrumentation is arranged in such a way that, okay, so on making a certain heating program or a cooling program, you can continuously observe the change in weight of the sample. Okay, so now this gives you many interesting results and useful parameters. Okay, now let us go one by one. Like what are the major parts I know that it contains. Okay, so one thing it should have a furnace. Obviously, all thermal analysis and a thermoanalytical method should contain a furnace. Furnace means the heating vessel. Okay, and you should have a microgram balance, right? Microgram balance. This is what I said in the earlier slide, that there should be two sensors. One sensor is to sense the change in the temperature. Okay, because your furnace should continuously measure the temperature. Obviously, without measurement, you can't do any kind of analysis. And this is the property we are going to study, that is the weight, and hence change in the weight can be determined. Now there is no sensor, but it is, of course, this is a balance. Okay, a microgram balance, very sensitive balance should be there, should be used for this purpose. Okay, any minute changes in the weight loss or weight gain should be properly recorded. Okay, because that gives you information. And of course an auto sampler and a thermocouple, right? Auto sampler, of course, why this is required is these are the instruments which are run at a high temperatures. Okay, then when you are using such a material, such an analysis, it's quite difficult to manually handle things, and hence the sampling, everything, that can be automated. So it is better if you have an automatic sampler, right? And a thermocouple is a device which measures the which records the temperature. You can't use the mercury thermometer for measuring the temperature, because it has a limitations. Okay, so you can use it to the boiling point of the mercury, so beyond which you can't go with the usage of mercury. So that is a serious limitation. So instead of that one, we go with the thermocouple. So that gives you the accurate measurement of temperature. Okay. So this is a technique in which change in weight of a substance is recorded as a function of temperature or time. Okay. Thermogrammetry is a technique in which change in weight of a substance is recorded as a function of temperature or time. So it could be any of these. Instrument used for thermogrammetry is called Thermo Balance. Okay, now this is a particular term used in thermal analysis, or a thermogravimetric analysis is also, or it is abbreviated as TGA, Thermogravimetric Analysis. Okay, and we are getting acquaintance with these terms also. That's what I am repeating these things again and again. Instrument used for this thermogrammetry is a thermo balance, and data recorded in the form of curve, and that is called as a thermogram. So thermogravimetric analysis, and for that we are using thermo balance. And by using thermo balance, when you do the analysis, finally the final output what you get is called thermogram. Like like in case of spectroscopy, you use a spectrometer. Spectrometer is a device, and spectroscopy is a concept, or the process that you normally carry out. And finally, that what is end up is called the spectrum. Okay, the spectrum is what is end up with the the final output. Okay, the whole the method is called certain spectroscopy. It could be UV visible spectroscopy or IR spectroscopy, like that. So similarly, thermogrammetry involves these terms. The furnace can raise the temperature as high as 1000 degrees Celsius, which is made up of quartz. Okay, so because the furnace, whatever you use, it should the very basic essential aspect is it should withstand a high temperature. The very vessel should not decompose in the due course of heating. So you should have a strong material like quartz, which can withstand very, very high temperature as well. The auto sampler helps to load the samples onto the microbalance, okay, and the thermo balance. The thermocouple sits right above the sample, because thermocouple is the one which is a temperature sensor which has to be there in very close association with the sample, because it has to record the temperature that is actually felt by the sample. So you can't keep the thermocouple anywhere else except near to the sample. Care should be taken at all times that the thermocouple is not in touch with the sample which is in a platinum pan. Of course, it should not directly touch, but it should be in a contact. It should have an immediate contact, but not directly, because if you are using some chemical substance, it should not react and harm the entire analysis. Now this is the thermo balance what you are seeing, or for in what is being used in TGA thermogrammetric analysis, a technique that permits continuous weighing of a sample as a function of temperature and function of time, as a function of temperature or as a function of time. Okay, it all depends. Sometimes both temperature and time is recorded in the axis, okay, at a desired temperature. All right, so then we can just look at this. The picture is quite not clear. However, you can see the this is the place. Okay, this is actually a place. So which is this heating is done. Okay, so this you can just imagine this is a furnace here, right? And that is connected to a balance. Okay, it is connected to a balance. Means it is continuously weighed. It is continuously weighed. Now it's not like just exactly like what is mentioned here. It is just like a connecting. You have a balance, and one of the pan is kept away, and another pan is here, so that it is not like you can continuously put the weights here and keep on watching the pointer movement for making it 0. No, everything is normally automated. So the measurement of weight is continuously being taken. Okay, so as with a heating program, but in order to make you understand this concept, the picture is like this, right? And there is some inlet and outlet. All these things are there to make movements of some gases that normally produce. Okay, on heating, there are another thing that you can as a analytical requirement, you can go with the maintaining certain heating atmosphere. Furnace atmosphere can be maintained like sometimes you need to have a inert atmosphere, then you have to supply the nitrogen gas in the furnace. Sometimes you need not maintain any inert atmosphere. It could be an ambient atmosphere. For ambient atmosphere, but still you cannot just simply enclose everything, so that there will be a lot of accumulation of gases which might otherwise cause explosive hazards. Then it is better to keep open and also keep it flushing with some purge gas. It could be nitrogen or argon or any noble gases. Okay. So here is a heating, means it is a furnace, and is a one of the pan connected to a balance, and you are continuously measuring the weight as the temperature increases. This DTA we come across later, and this, and again you can see another picture. So initially we go with one or two slides which might repeat the concept, but tries to give you different outlooks. Okay, so yeah, everything the same what I said earlier. Here is a balance, means it is continuously measured. Weight of the sample is continuously measured, and while it is kept in a heating furnace. Okay, and there is a purge gas. See, always remember, this is a very particular term that is normally used, purging. Okay, so don't forget this term. Whenever you are doing a reaction, and if the reaction atmosphere is to be maintained with a particular gas, then you have to pass that gas into that reaction vessel, and that process is called purging. That process is called purging. Okay, so or else the gas that you use for that is called as a purge gas. A purge gas could be nitrogen or carbon dioxide or argon. It all again depends. Okay, now this is a sample holder is taken and connected to balance and heating process. So fine. A technical a technique measuring the variation in mass of a sample, a variation in mass of a sample undergoing the temperature scanning in a controlled atmosphere. Okay, in a controlled atmosphere. Thermo Balance allows for monitoring sample weight, as a function of temperature. Okay, now as a function of temperature or time, you can also put it for time also. Okay, the sample hangs from the balance inside the furnace, and the balance is thermally isolated from the furnace. So this the balance actually the one which takes its measures its weight, it should be isolated because it should not get influence and it should not give a wrong result. So it is said it should be isolated from the furnace. However, we have to continuously get the weight of the sample in due course of heating. That's all. All right. Now there are something here in this slide. I think let me see to that slide little in a while. Before that, now let me try to give you the picture of thermogram first. Okay, when you look into the thermogram, then you understand. Okay, so how will be this? How will be the actual thermogram, and then we go to the that particular slide. Now here you see this is actually it's not quite clear here. This y-axis is a percentage weight loss. Okay, so this y-axis is normally percentage weight loss. Okay, and x-axis will carry sometimes it carries two things. One thing is a degree Celsius, another thing is a minutes. Okay, you can see both time and temperature. This what it has been several times defined that this TGA is a technique which measures the weight loss with a continuous with a change in temperature or time. Okay, so that's how the change in the weight loss is measured with respect to temperature or time. Okay, now this it's a faintly observed that you can see the temperature being increasing from ambient to 100, 150, 200 like that. It's reaching up to 8 and 900 or 1000. And here the time is calibrated as up to 30 minutes. Okay, so 0 to 30 minutes. On y-axis, sometimes it can be in milligrams. Okay, so weight loss directly you can get a normally you can't take the sample quantity in terms of kilograms or more than that here. The samples that are taken for analysis in this technique is only in terms of few milligrams. Okay, so very little quantity of the sample is enough for the analysis, and this is actually the thermogram of a calcium oxalate, and look at the value is given 19.0300 milligrams. So roughly it is 19 or near to 20 milligrams. Just a 20 milligrams of not even a gram. Remember, nobody will take the sample in terms of grams. Not even 1 gram. It is much less than that. Okay, that just a 20 milligram is taken and it is heated. So this y-axis, it can be milligram as well as percentage weight loss. Percentage weight loss, it is calibrated in such a way that, so initially when you begin with the ambient temperature means it's a room temperature. Okay, so if you keep on increasing the temperature, so when you proceed with the initial it will begin from the y-axis from here. Okay, the graph will gradually go towards the right side. So that is a normal tendency here. So initially, the whatever be the weight of the sample that you take up, the instrument calibrates that. Okay, takes that as 100%. Okay, that is taken as 100%. Now it all again depends, you know. You need not take this much only. You take I take 10.005 milligrams. Now when you take that much and just ask the instrument to calibrate itself, then it takes 10.005 milligram as 100%. Okay, and you start the heating program with a suitable heating rate. Then you record the thermogram. Then what happens? Gradually, in the due course of heating, there is a decreasing in the weight of the sample. So weight loss takes place. Okay, so then, as I told, y-axis is a percentage weight loss. So then, what happens is either you can get a reading in milligrams. That is also there if possible. Normally, it is a weight loss in percentage. So first one is a 0%. Okay, so weight loss. So when I'm talking about weight loss, the first reading the here should be 0%. It should increase from 0, 10, 20, 30 up to 100. Okay, so when there is no weight loss at ambient temperature, then there is a 0% weight loss. So gradually it can undergo weight loss, and finally it might settle to certain percentage of the initial sample that you have taken. So for the 19.03 gram, 3 milligram. So finally, what is left? It could be some. The weight loss could be 90%, right? And the 10% of the sample still remains, okay, without undergoing any changes to that material. It all again depends on the substance to substance, right? So if you take a fuel, everything might go away, okay, at certain temperature, leaving behind only the ashes, right? And also you can go for calculating the amount of non-combustible material present in a fuel. If you put a fuel for a thermal analysis, you can estimate its fuel content, the material that are actually catching that can catch fire, and also what all the other rest of the materials that are present. Those all things can be determined. The quality of the fuel can be determined by using this particular technique. All right. So today I could able to give you some glimpse of what is meant by thermal analysis and what is meant by thermogravimetric analysis. So in the tomorrow's class, tomorrow my regular class is there from 1 to 2 o'clock. Okay, in the tomorrow's class, let us go with the continued discussion on this one, on these slides, and also I have many other slides. Okay, let us try to have a deeper discussion on this TGA, and then we move on to DSC and DTA also. So my estimation is that it might take 2 or 3 more classes to complete the discussion on this thermal analysis, and later I go with the NMR technique, and after that I'm left with one more thing. There is a this is a ion exchange chromatography. So that will end my the entire syllabus. Okay, so this is the idea. I think time is up. Wait for a second. I just download your attendance. Okay, so is there any doubt? You can have an interaction. I got your attendance downloaded. So you can, if you have any doubt, you can just talk to me, or else you can even leave the class now. I assume that slides were visible. Later, I got the information from Pawan that I initially the volume was down. later I think, I hope everything was okay. Fine, if there are no questions, you can leave the class. Thank you.
Thank you, sir.